this video, we are going to see a problem on projection of planes. For that, here is a question. It is given that a square lamina is the other word for the plane ABCD of 50 mm side rests on the corner A in HP such that the plane is seen as a rhombus in the top view, with diagonal contained by corner A measuring 25 mm. Draw its projections and determine the surface inclination of the plane with HP. So let us start this question. Here there is XY line, then there is VP HP. In the question it is given that square lamina, which is a square plane ABCD of 50 mm side, rests on corner A in HP. Now if it is resting on one of its corner in HP, it means the entire square plane is in HP. It means it is visible from the top as a square. So I'll be drawing that square resting on the corner in HP. Selecting a point. Next, since it is resting on the corner, measuring 45 degree on both the sides of this point. Taking 50 mm side as it is given in the question. Already it is 50. Taking the distance in the compass. 50 mm on the other side. Then drawing a light arc. Cutting it from the other side. Here I am getting this point. Joining it light. Giving the notations. So this is the top view of the plane, and here is the front view which appears as a line. Now after I have drawn this square plane as the top view and front view light, now I'll make it dark. So here is the square plane as it appears in the top view. This is the front view. Now in the question it is given that square lamina, which is a square plane ABCD of 50 mm side, rests on corner A in HP such that the plane is seen as a rhombus in the top view. Now it is appearing as a square, but in the next case it will be appearing as a rhombus with diagonal contained by corner A. Now the diagonal contained by corner A will be diagonal A to C, that is diagonal AC. So diagonal AC measuring 25 mm. It means in the next case the length of the diagonal is given, which is passing through point A. It means A to C will be 25 mm. Draw its projections and determine the surface inclination of the plane with HP. Inclination with HP will be visible in VP. It means in the next condition this line will be inclined, but that inclination is not given. They have given the condition in this form that the square appears as a rhombus. So I'll be drawing that rhombus here. Now the length of diagonal AC is going to change, but the other diagonal BD is fixed. So for that I am drawing a light vertical line. Diagonal BD. Next AC. For that the length is 25 mm, it is given, measuring 25. So from BD I'll measure 12.5 on one side, 12.5 on the other side. That gives me 25 mm length. Joining all these points light. So here this rhombus is seen in the top view. That explains that this square plane, which will be fixed at point A, now it will be tilted, that is keeping point A fixed. I am going to pick this square plane from here and then going to tilt it in such a way that AC will become 25 mm. So now this is the tilted square plane. and it is seen in the top view, it means this line which was horizontal previously, now that line will also become inclined. So for that, I'll keep point A as fixed, projecting point C upwards. Next, here this plane will be inclined, that is through A dash I have to draw an arc in such a way that it cuts this line which is passing through point C. For that I have to get the length of the cutting, length of this square plane, which is from A dash to C dash. Keeping it on A dash, I'll be cutting this line. So that is giving me the point C dash. Next, I'll measure the distance from A dash to B dash D dash, cutting this line B dash D dash. Next, I'll make it dark. So this will be the inclined plane and its top view is here. So here I'm making this square plane dark. And this is the inclination. Inclined to HP seen in VP, this angle is called as theta. Next, I need to find this angle. So I'm going to measure it. And when I'm measuring this angle, it comes out to be, it is 66 degree. So I'll say that therefore the inclination of the square plane with HP is theta is equal to 66 degree. That's the answer. Next, here I can say that the square plane, previously it was kept in HP, that is on the ground about corner A, then it was tilted about the same corner, and here when it is tilted about 66 degree, this diagonal AC will become of length 25 mm as it was given. The last thing which is left here is the dimension. So I'll just give the dimension to this square plane, 50 mm side, and then this diagonal AC. Diagonal AC is 25 mm, and here I can say that this is the true shape and here is the apparent shape. And with this we complete the problem.